simply get longer until you found the next stop codon. It could affect the activity of the protein, and may or may not affect the activity of the protein. Chances are it probably wouldn't affect the activity of the protein. We can add sequences to proteins in the labs without much consequence, to be honest with you. The larger problem is this. What if you have a mutation in a tRNA gene such that the anticodon is changed so that it now recognizes stop codons? Right? So you take a tRNA that's supposed to fit, for instance, into the tyrosine tRNA synthetase. And instead of having an AUG anticodon, it now has an AUC anticodon, which is going to pair against a UAG stop codon. And now instead of stopping protein synthesis, you actually insert a tyrosine in its place. And since the stop codon or the punctuation is used across many, many genes, you're now extending the length of many, many genes by putting a tyrosine in and potentially letting additional codons downstream be used. Now, these are really important. It's beyond the level of the class, but I think it's important for you guys to realize what you can do with these. You can take a gene of choice, for instance, and purposely decide that at position 47, you want to put in some really interesting residue. Say, not even a natural amino acid. Well, if you can make a tRNA with a non-natural amino acid on it, and we can, and you can attach it to a tRNA that normally recognizes the stop codon, you can have a gene that is translated to put in regular amino acids, then it can put in your special amino acid, then it can go back to putting in all the rest of the amino acids. So you can put non-natural amino acids inside proteins by using nonsense suppressor tRNA. Dieter Sohl's group at Yale has perfected this to put in amino acids that are fluorescently labeled so that we can see proteins move around in cells in real time. They've also put in residues into the amino acid polypeptide chain such that they can attack one protein to another or attach them covalently. You can put in a wide variety of modified amino acids to look at the specific effect of phosphorylations or methylations, and you can make a wide variety of quote-unquote mutant proteins this way by being able to doctor anything in you want. And in fact, those groups have gone so far to look at like an organism like E. coli. There are 3 stop codons. All 3 of them work. If we re-engineer E. coli so that it only uses 2 of the stop codons to actually stop, we've just got ourselves an extra codon to play with. And they've genetically engineered E. coli that can put in residues in vivo using that nonsense codon now as a coding codon. And I imagine large technology will come from it in the future. Other queries or questions? That's it for today.